Audible to everyone?
Yes, sir.
Huh? So, do you have any doubt from the last class to anyone of you?
No, sir.
Have you solved your assignment? Riba? Sabita, have you solved your assignment? Riba,
Yes, sir.
have you solved your assignment?
Which one, sir?
I think sir would send you, some assignment regarding dimensional
Application of
analysis.
diamond.
Yeah.
Application of diamond. Yes, sir, I completed that.
Okay. So, any doubt?
No, sir.
Good. So we were doing in last class, that is third application of dimensional analysis, on which I have just defined you two different questions. Let me give you one more problem regarding that. The time period of a planet revolving around the sun depends upon mass of sun, gravitational constant, and distance from sun. Put k is equals to 2 pi and try to derive relationship. Try to simplify on the basis of last concept which we had did in last class. Umar, do you have any doubt from the last class?
No, sir.
Good. I've just given a question regarding the last concept which we have did in last class. Try to solve it, everyone.
Could you read out the question for me? I'm unable to understand it.
Time period of a planet revolving around the sun upon mass of sun and universal gravitational constant, that is capital G, and distance from the sun, that is R. Do you have any doubt from the last class?
No, sir.
Abdullah?
No, sir.
Riba, there is some error in your calculation. Let's say we have time period, which is equals to some proportionality constant K, and its dependency factor is M raised to the power X, gravitational constant G raised to the power Y, and radius or distance from the sun raised to the power Z. So this would be your formula for this particular time period. So the first step is to write dimension formula of left hand side and right hand side. And on the basis of that, compare the coefficient or compare the exponential of each part to find X, Y, and Z. Okay?
Yes.
Try to solve.
So here we can ignore G, right?
Yeah?
Here we can neglect G, right? Gravitational
Why
constant.
G? Why we have to neglect this particular G? This is gravitational constant. Capital G is having dimension m raised to the power -1, l raised to the power 2, and t raised to the power -2.
Sir, we can neglect K, right? Dimension does not.
Yeah. K is just proportionality constant, so we have to neglect on the basis of dimension. Yeah, are you solving or in doubt?
Yes, sir.
Do you have any doubt while solving?
I'm trying.
Okay. Sabita, any doubt? Your answer is correct.
So are the values correct?
Yeah. Now put all those values and try to simplify. Umar, just check your calculation.
So while simplifying, do we have to use k as 2 pi?
Yeah. Rishan, why is you late? Just see how to proceed it. Let's say we have d in left hand side. So its dimension formula would be n0 L0 t raised to the power plus 1. In right hand side, we have k, which is dimensionless part, so we neglect it. Then next is m raised to the power x. G is gravitational constant having dimension m raised to the power minus 1, L raised to the power 2, 3, and t raised to the power minus 2, whole raised to the power y. R is nothing but length having exponential z. So it would be m raised to the power x. We have minus 1 to the power y, so it will become minus y. L raised to the power 3 and multiplied by y, so it will be 3y, and t would be minus 2 into y and L raised to the power z. So on simplifying, it will become x minus y, L raised to the power 3y plus z, and t raised to the power minus of 2y. This will be your final expression. Now compare the exponential of each part. Suppose for m is equals to m, we have in left hand side the exponential of m is 0, and in right hand side the exponential of m is x minus y. So on comparing, we can say x minus y would be 0. Similarly, compare the exponential for L. So it would be 3y plus z is equals to 0.
So why it would be 0, x minus y?
Just see the exponential of left hand side for this particular mass.
Okay.
As we have exponential for mass in left hand side is 0, so the exponent of mass for the right hand side must be 0 according to principle of homogeneity. It tells you if two quantities are related by any is equals to sign, it means the dimension of left hand side and right hand side of each term should be equal. That's why I've just compared them. Similarly, compare the exponential for t. So it will be minus of 2y is equals to 1. So from this, y would be minus
So
1 over
isn't that
2
minus 2z?
minus 2z.
Yes.
No. Here we have t raised to the power minus 2 and exponential is minus y here. So if you bring this particular y to this, so it would be 3 times minus 1 by 2 plus z is equals to 0. So z would be plus 3 by 2. If you again put this value in this expression, it would be x is equals to y, which is equals to minus 1 by 2. Riva, I think you have taken a different part. We have taken r to the power y and g to the power z.
Yes, sir. I've done that.
Okay,
Is it okay?
yeah. You may take either of them. Neither your answer is correct.
So x would be plus 1 by 2. So x would be
Why?
plus 1 by 2, right?
No. If you bring this particular y to the other side, since it have negative sign here, so on going to the other side, it will become positive. And the value of y itself minus 1 by 2. So the value of x and y would be equal. Okay, Mohammed Umar?
Could you explain that again?
I've just defined the dimension of mass in left hand side is nothing but m raised to the power 0. Just see here. And just see in this right hand side segment. Just compare the exponential of each part towards left hand side and towards right hand side. Okay. So as we have m raised to the power 0 in left hand side and m raised to the power x minus y to the right hand side. So on comparing, it would be x minus y would be 0. Okay, Rishan? Muhammad Umar, any doubt? Iram, do you have any doubt?
Solve the minus equals to 0 by putting the value of in it.
What, Umar?
Could you solve the expression x minus y equals to 0 by putting the value of y in it?
Okay, just 1 minute. Similarly, on comparing the exponential for L, here we have L is to the power 0 in left hand side And in right hand side, we have L raised to the power y plus 3y plus z. So 3y plus z would be equals to 0 on comparing right hand side and left hand side. Similarly, there is one more term, that is t raised to the power plus 1 in left hand side. And here we have t raised to the power minus 2y in right hand side. So on comparing, it would be minus 2y is equals to 1. Aaron, is it clear?
Yes.
Okay, so on this particular basis, I have just solved y is equals to minus 1 by 2. Put the value of y in the second equation, it will be minus 3 by 2. If you bring this term to the other side, it will become plus 3 by 2. Now, if I have to solve for this part, x minus the value of y is minus 1 by 2 is equals to 0. So here minus and minus, so it will become plus. So we're left with x plus half is equals to 0. So if we bring this particular to the other side, it will becomes x is equals to minus half. Is it clear, Muhammad Umair?
Yes, sir. Clear.
Now we have solved all different values of x, y, z accordingly. We have x is equals to minus 1 by 2, y is equals to minus 1 by 2, and z is equals to plus 3 by 2. Put the values of these terms in the first equation and try to simplify it. First of all, write it down, all of you, those who haven't solved. Rishan, any doubt? Still you have doubt? Just ask. On comparing, I have just compared the exponential of m to the exponential of m. Just see the exponential of m to the left hand side and exponential of m to the right hand side. Similarly, compare the exponential of length to the left and right. Similarly, compare the exponential of time to the left and right. Good, Umar. You are too intelligent. I've already mentioned it here. It is just capital G, and I have written the dimension here as well. Solve once again, Umar. Good. Now, we have to put all these values in this particular expression and we have to simplify it. Just put the value of k to be 2 pi, x to be minus 1 by 2, y to be minus 1 by 2, and z to be 3 by 2. Have you all written till this part? Rehab,
Yes, sir.
Yes, sir.
Rishan, Sabita, done?
Yes, sir.
Okay. So now we have to simplify it. So t is equals to k means 2 pi, m raised to the power x means plus minus 1 by 2, capital G to the power y, which is minus 1 by 2, and r raised to the power z, which is 3 by 2. So it would be 2 pi. These negative power would become positive if we move in denominator. So it will be r raised to the power 3 by 2 divided by g raised to the power plus half and m raised to the power plus half. We can simply write it as r to the power 3 and whole to the power plus half. Similarly, g and m both containing power half. Now take power half to be common from each part. So it will becomes r to the power cube divided by gm and whole to the power half. As we have discussed in the last class, if exponential is half, it would mean square root over the entire part. So we're left with nothing but 2 pi root under r cube divided by g times m. Is it clear to everyone?
Sir, how 3 by 2 became 3 for r, the exponential of r?
Since we have x to the power m to the power n, so it will becomes x to the power m into n. So we can write 3 by 2 as 3 into 1 by 2. We can write it like this. Muhammad Umar, can we write this particular part like this?
Okay, sir. Yes.
So I have just break this particular exponential into two parts and put it after bracket. Riba, is it clear now?
Yes, sir.
Since I have to make common exponential from all of them, and all of them are containing plus half, plus half, plus half. So I have just derived or break this particular exponential to 3 into plus half and taken out plus half common from either of all three parts. Okay, Rishan? You may leave your answer to this point as well, or you may solve further like this. Have you all written?
Yes, sir.
Yes, sir.
Yes, sir.
Aram? Done?
Yes.
Sabita?
Yes, sir. Finished.
Good. Suppose if you have another relation, like there would be some question like if gravitational constant capital G, Planck's constant h, and speed of light c. Using this, find dimension of, no, you have to find formula or maybe dimension of length. But k is equals to 1. So use same concept. We have L is equals to some proportionally constant k What are the depending factor? We have dimensional constant capital G, Planck's constant small h, and a speed of light c. So let's say g raised to the power x, h raised to the power y, and c raised to the power z. So this would be a formula. We have to define the value of x, y, and z using dimension analysis and put them all and try to obtain the relationship. Let me give you dimension formula for each of them. G is nothing but m raised to the power 1, L raised to the power 3, and P raised to the power minus 2. Planck's constant H is ml squared T raised to the power minus 1. C is nothing but speed of light having dimension LT minus 1. Just put them all and try to simplify for the value of x, y, and z. Here L is length, so you take capital L, or in terms of dimension, you can take raised to the power 0, L raised to the power 1, and T raised to the power 0 in left hand side. As there is no any mass and no any time term in left hand side, so just write the dimension like this and try to simplify. Muhammad Umar, any doubt while solving?
Not yet, sir.
Good. We have
Awesome.
Iram, any doubt while solving?
No.
Just put the dimension of capital G, this, H, this, and C, this. And try to simplify to calculate the dimension of M only, L only, and T only. First, try to do so. Rishan. Just put the dimension of each segment on their respective positions. Put this particular value in this position, this value in this position, and this value in this position. After that, simplify the exponential of M, L, and T. Nida, have you solved?
I'm solving.
Okay.
So while comparing, can we get the value of x in terms of y?
Yeah, you may. We have K, which is proportionality constant. So in terms of dimension, we can neglect it. On putting the value of G, it was minus 1 L raised to the power 3 T raised to the power minus 2 whole raised to the power x. Similarly for H, it would be ml square T raised to the power minus 1 whole raised to the power y. And for speed of light, LT minus 1 whole raised to the power z. So on simplifying, it will become m raised to the power minus x L raised to the power 3x and T raised to the power minus 2x in the first bracket. In the second bracket, it would be m raised to the power y, l raised to the power 2y, and t raised to the power minus y. In third bracket, y raised to the power z and t raised to the power minus z. So now compare the coefficient of m. We have m raised to the power x here, m raised to the power y here. So it will be minus x plus y. L raised to the power 3x, L raised to the power 2y, and L raised to the power z. Similarly, for time, it would be minus 2x, minus y, and minus z. So this would be your final expression. Just check, have you all got the same expression or not?
Yes, sir.
Sir, can we write raised to 2y minus z?
Mohammed, just tell me once again.
Can we write t raised to 2 as z, negative signs?
Now, since we have t raised to the power minus 2x here, minus y here, and minus z here. So all these terms are in multiplication. So we have to add them as their own sign. So we can write minus 2x, minus y, and minus z.
So,
Where it is 2y, minus 2x here, minus y here.
sir, minus 2x minus y will become 2x plus y, right?
No, if it is equals to 0, then it will becomes plus. Or you can take negative sign from either of them as coefficient or as common. Let me solve it. First, on comparing for the exponential of m, it would be minus x plus y would become 0. Similarly, we have 3x plus 2y plus z is equals to 1. And the last part is minus of 2x, minus of y, and minus of z is equals to 0.
Sir, I got the same thing.
Good. So first of all, it will be easier if you add this equation and this equation. So if I put this equation here, it will be minus of 2x, minus of y, and minus of z equals to 0. Now simply add them. On adding, it will become 3x minus 2x, x, 2y minus y would be plus y, and z would cancel out. So we're left with just 1. Now put this value in this expression. So it would be x plus y is equals to 1. So on adding, x and x would cancel out. Y plus y becomes 2y is equals to 1. So solve y from this part, put it to this part.
Sir,
And
why
put the
are you
value.
adding them?
You must have learned how to solve linear equation, 2 variable, 3 variable, and so on. There was a method which is called elimination method. So I'm just trying to eliminate one variable each time.
Okay, understood.
I have just seen this particular term, z to be plus here, and here we have z to be minus. So if we add these two equations, z would cancel out. So we're left with just 2 variable. Okay, Muhammad Umar?
Okay, sir.
Similarly, if we have x to be plus sign here and we have x to be minus sign here. So if I put this particular equation here, this x and this would cancel out. So we're left with just only y. This is some trick to eliminate some variables so that you can easily solve the rest of them. Now try to simplify it, each of the term. Ishan, just see the dimension formula of left hand side. We have length here, so in terms of dimension, we can write it as m raised to the power 0, L raised to the power 0, L raised to the power 1 as we have L only, and T raised to the power 0 as there is no any term of mass and time in left hand side. So while comparing the exponent of m towards right hand side and towards left hand side, minus x plus y would be 0. Similarly, just see the exponential of length towards right hand side and towards left hand side. Similarly for time as well. Okay, Rishan? Good. Just find y from this equation, put it to this equation to find x. On putting values of both x and y in this equation, you will find the value of z. They have any doubt in calculation?
No, sir.
Good. Yes, Rishan? First of all, write values of x, y, and z. Send it to me first. Rishan, there would be some different exponential of x, y, z. Umar, just 1 minute. Umar, it would be in fraction. Good, Sabita. Good, Riba. Rehab, send me the other one. You have just sent one of the answer. Rishan, just check from this equation. Here 2y is equals to 1. So y would be nothing but 1 over 2. Put this particular value of y in this equation and try to find this x. Now on putting the value of both x and y, you would find z. Riba, try to simplify the expression according to the exponential you got. Savita, you also.
What?
Try to simplify your answer as we did in last problem, like this.
Yes, sir.
Iram, send your answer, please. Nida, Abdullah, Sabita, check your calculation once again.
Okay, sir.
Yeah, there is some mistake in calculation or in value of z. And I have just given the value of k to be just 1. From where you got 2 pi. Just see, we have calculated y is equals to plus half. On putting it to this equation, it will become x plus half is equals to 1. On bringing it to the other side, it will becomes or get subtracted. So x would be equals to 1 minus 1 by 2, or it would be just plus half. Good, Nida. Now put the value of x and y in this equation. It will be minus of 2, x is plus half, minus y, which is equals to plus half, minus z is equals to 0. 2 and 2 cancel out, or you may leave it as it is. If you take LCM to be 2, we have minus 2, minus 1. Bring this particular z to the other side. So it would be z is equals to minus 3 by 2. So we have x is equals to plus half, y is equals to plus half, and z is equals to minus 3 by 2. Iram, have we got the same answer? Tehad, check your calculation. Z would be minus 3 by 2. Okay, now we have to put these value in this expression. So L would be K, which is equals to 1, G raised to the power X having power 1 by 2, H having raised to the power Y, which is equals to plus half, and C raised to the power Z, which is equals to minus 3 by 2. We can write it as G to the power half, H to the power half, divide by, since this particular exponential contains negative, so you can write 3 by 2 in denominator. Now just see, we have 3 upon 2, so we can write this particular term as 3 into 1 by 2. We have just break this particular term like this. Since we have plus half common in numerator, so we are just trying to take common plus half from this part as well. So we can write GH to the power half divide by C to the power cube and whole to the power half. Now take half exponential common from all of them. So it will becomes root under GH divided by CQ. Is it clear now? Yes, Abdullah, tell me. Okay, just 1 minute. Have you understood this? How I solve X, Y, and Z?
Yes, sir.
Okay, those who haven't written, just try to write it down. Muhammad Umar, any doubt? All of you have written this?
Yes, sir.
I've just put all the values of X, Y, Z on their respective positions. As we have in the last part, L is equals to K, G raised to the power X, H raised to the power Y, and C raised to the power Z. And we have just obtained X is equals to half, Y is equals to half, and Z is equals to minus 3 by 2. So I just put all these values of X, Y, and Z in this expression like this. Now, since C containing negative power, so on bringing or switching any of the term from numerator to denominator or denominator to numerator, its exponential would change to negative sign or negative would change to positive sign. That's why I have just bring this particular term to the denominator to make this particular exponential to be positive. Okay. Now, since we have plus half exponent for both these two terms, so I want to make exponential plus half common from this part as well. So I have break this particular 3 by 2 as 3 into 1 by 2. And as we know, exponent to the exponent gets multiplied. So we may write this particular term like this. Okay, Abdullah? That's why I have written this particular part like this. Now I have taken common out from all these segments as plus half, and we know exponential half is nothing but square root. So your final answer would be this for calculating length. Okay. So do you have any doubt, any one of you till this part? Rishan, Iram,
No.
Mohammed Umar?
No, sir.
Good. Have you all written this?
Yes, sir. Yes, sir.
Done? So we have just finished all different topics related to this particular dimension analysis. Now there is some limitation of this particular dimension analysis. Limitations, or you may say there is some demerits of dimensional analysis. The first demerit is, with the help of this dimensional analysis, we can't define the value of proportionality constant. Likewise, we have done in the last problem, in last class, for calculating time period of simple pendulum, it was 2 pi root under L over G. So I have just given you there, K is equals to 2 pi. This particular 2 pi is nothing but any constant. And with the help of dimension analysis, we can't be able to define this particular proportionality constant. This value is defined or derived by using experiment. So this is the limitation or demerit of dimension analysis. With the help of dimension analysis, we can't be able to define proportionality constant. So it is unable to calculate the value of proportionality constant. Next demerit is, in all of the previous problem, if you analyze, I have just written only 3 terms, means a quantity Q based on just 3 terms. If you see in all of the previous problem, like in this part, I have given you time period depends upon just 3 part, G, M, R. Similarly, in this problem, I have given you length depends upon just 3 part, G, H, and C, and so on. So it means dimension analysis is valid to derive relationship up to 3 different quantities only. Above than that, it would give you wrong result. So it is applicable to derive a relationship up to 3 terms only. Beyond that, it would give you a wrong answer. There is one more limitation. In all of the previous problem, I have just defined you to find relationship, whether that relation is in product or in division. We haven't solved any problem related to plus sign or minus sign. Suppose if you have equation like S is equals to ut plus half at squared, v square is equals to u square plus 2gh, and so on. These relationship which contains some plus sign or minus sign in between them are called as composite relationship. These are called as composite relationship. And with the help of dimension analysis, we won't be able to calculate this particular relationship. Okay? So it is not applicable to derive composite relationship. It is applicable only to derive product or quotient relationship. Is it clear to anyone, everyone? Or any doubt in any of the topic?
Sir, can you repeat that from S is equal to UT?
We have S is equals to UT plus half it squared. This is just equation of motion. We may have pressure plus half rho V square is equals to some constant. So these type of equation in which there is a relation between any of the two quantity by plus minus, other than multiplication or division, those type of relations are called composite relationship. And with the help of dimension analysis, we would not be applicable to derive that type of relationship. Using dimension analysis, we would derive only product and quotient relationship, not as plus or minus sign. Is it clear to everyone?
Yes, clear.
Aram? Rehab,
Yes.
any doubt?
No, sir.
Good. Just write it down. Yes, Rishan. Which one? Dimension analysis is not applicable to derive relations beyond or more than 3 terms. If there is a quantity which is related with some quantity beyond 3 terms, like 4 terms, 5 terms, or 6 terms, it is not applicable to derive that type of relationship. It is applicable only to derive up to maximum 3 terms only. Like we have just derived this length, which is depending upon G, H, and C, just 3 terms. Similarly, we derived in the earlier part, time period, it depends upon just 3 terms, R, G, N, just 3 terms, maximum. Beyond 3 terms, it would give you different result or wrong result. Third limitation is the relation which contains plus sign or minus sign are called composite relationship. And with the help of dimension analysis, with the help of dimension analysis, we won't be able to derive these type of relationship, as dimension analysis gives you result on the basis of product and quotient. Quotient means division. These type of relationship which contains product or division relationship. V square, U square, you may write it as 2GH or 2AS. Here we have pressure half rho V square.
So could you explain the fourth point? Applicable only to derive product and quotient relation.
Product or quotient means A into B into C. It would be like this, or it would be A into B divided by C, like these type of relationship. These type of relationship would be applicable to derive using dimension analysis, but A plus B like this, A minus C like this, these won't be possible using dimension analysis. Okay, Mohammed Amir? Abdullah, any doubt? Good. Have you all written?
Yes, sir.
Rishan, done?
Yes, sir.
Sabita,
Yes, sir. I finished.
good. So the next topic in this chapter is error analysis. In this particular error, let me define you first two terms. First is, we call it as error analysis, or simply called theory of error. In this particular part, let me define you accuracy and precision. Do you have any idea about these two words? Anyone of you?
Yes, accuracy is the closeness of the measured value to the true value.
Good. And what about precision?
It is the extent to which a calculation is done.
Okay, good. Let's say if you have to calculate the value of gravity, g, small g, it is nothing but 9.8 meter per second square. If we done an experiment to find this particular value, in your class 11, there was a experiment using simple pendulum. You have to derive this particular gravity. So if one of a student calculated like this, 9.84, the other one has calculated like this, 9.79, 9.76, and so on. So check which of the following experimental value is the most closer to this particular actual value. So your answer would be this part.
9.7.
Good. So the experimental value, which is most close to this particular exact value or accurate value or true value, defines you nothing but accuracy. So inaccuracy is nothing but the closeness of any experimental data with true value or exact value. So we can say 9.79 is the most accurate in all of this particular experimental result. Is it clear to everyone? What do you mean by accuracy?
Yes.
So the next part is precision. To define precision, we must need some instrument, and you must have learned one topic, that is least count. Least count or LC. Mohammad Umar, please explain it.
Explain what?
Least count, do you know?
Yes, it's the limit of an instrument to which calculation can be done.
Okay, just
I
one
mean,
minute.
like for vernier caliper, it is 0.01. That's the limit. To that extent, you can measure
0.01 meter, centimeter, millimeter, or what?
millimeter. Millimeter.
No. Let me explain you. First, Rishan, inaccuracy, since we have these type of values, which we have just calculated experimentally. So we can say these are experimental data, which is being calculated using some experiment. So just compare these experimental value with the actual value, or you can say this is your true value. So the experimental data which is the most closest to this particular true value, is called most accurate data. But for the precision, we must define least count. Least count is nothing but the smallest measurement an instrument can measure is called least count. The smallest value an instrument can measure is called their least count. Suppose you must have using your ruler from your childhood. There was some marked position like 0, 1, 2, 3, and so on. In any of the two consecutive gaps, there must be some 10 gaps, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5, and so on. So in total, from 0 to 1, we have 10 divisions. Have you all noticed it?
Yes, sir.
Okay. And this particular measurement is in nothing but centimeters. So we can say 1 centimeter from 0 to 1 is divided further into 10 division. So if I have to measure the value of the smallest part from this part to this part, what would be its value? Nida?
Minus
Hiram?
1.
I'm just asking about in terms of these terms. I've just divided 1 centimeter into 10 division. So it means 1 divided by 10 part in terms of centimeter, and we can call it as 1 mm. Is it clear to everyone?
Yes.
So this is the smallest division which we can measure with the help of this meter scale. So the smallest division or the smallest value an instrument can measure is called as least count. So the least count of meter scale is 1 mm or 0.1 centimeter. Similarly, we have different types of scale, vernier caliper, screw gauge, then pyrometer, and so on. Depending upon, we have different types of different least count on the basis of their divisions. So on the basis of this particular least count, if an instrument is used to measure any particular value, like if you have pen, there must be a refill in it. If you want to calculate the width of that particular refill or width of the nib of that particular pen, first, if you measure using meter scale, it would be around 1 mm. If you use the same measurement using vernier caliper, it would give you something different result. Using screw gauge, it will give you something different result. Accordingly, you can measure like 1 with this particular ruler. With the help of vernier caliper, it will give you 1.2 mm. With the help of screw gauge, it will give you 1.24 mm. Like these values. So what is the difference between these values? Mohammed Umar, can you explain?
Explain what?
Why we obtain these type of values using different scales?
For precision.
This is for meter scale. This is for vernier caliper. And this is using screw gauge or screw gauge. Using different scale, their least count would be different. And on the basis of their least count, Smaller the value of least count, it will give you more number of digits in the calculation. It means it would calculate up to more decimal segments. So whenever you measure the same term using meter scale, it will give you just one digit in terms of mm, as its least count is 1 mm. So it can't measure beyond or smaller than 1 mm. So it will give you just one digit, but using vernier caliper, it gives you two digits, but in terms of screw gauge, it will give you three different digits. And on the base of number of digits, we define precision. So in this whole different three calculation, we can say this is most precise measurement. Is it clear to everyone? What do you mean by precision? So precision defines you nothing but according to the least count. Smaller the value of the least count of the instrument, it will give you more precise result. So from this, you can conclude smaller the least count of an instrument, it will give you more precise result. Any doubt to any one of you in these two topics?
No.
No, Muhammad Umar. Smaller the value of the least count. I have just defined. Smaller the value of the least count, it will give you more precise result. Suppose if you have meter scale, its least count is 1 mm. For vernier caliper, its least count is 0.01 mm. No, 0.1 mm. 1/10 of this. Similarly, for a screw gauge, it would be 0.01 mm. So the smallest least count in either of these three instrument would be for screw gauge. So it will give you more precise result. Precision has something different meaning as well. I'm defining you later. First of all, write it down, all of you. Nida, is it clear?
Yes, sir.
Rehab,
Yes.
okay. You may memorize this particular precision as closeness of experimental data within themselves. Is called precision. I'm giving you some examples regarding this. Have you all written?
Yes, sir.
Rishan, done? Mohammed Umar, done?
Yes, sir.
Okay. Accuracy and precision may have different meaning according to significant figure, according to least count, and according to the true value. I've just defined according to the true value. According to the true value, accuracy means the closeness with respect to true value, and precision has nothing to do with the true value. It tells you the closeness within themselves. But according to significant figure, it has something different meaning. I will explain later. So on the basis of these results, let me give you some expression to define. Let's say if you have if there is a game of throwing and you will get maximum point if you hit this centralmost part. So in measurement, you can say this central part is the true value. And as we move away or out of this particular center, it means you are just getting deflected or getting deviated from actual value or true value. So we have different segment like this, this, and this. What these all term actually define you. First for accuracy and second for precision. Just see in the first part, all the values are in the center. It means closest to the true value. It means accuracy would be high or low.
Hi.
Good. Next, just check whether all of the experimental value are being closer to one another or not.
Yes.
They are closer, so we can say their precision must be high. Is it clear to everyone?
Yes, sir.
Iram, is it clear?
Yes.
In the second example, just see all of these particular experimental value are deviated or away from this particular true value. So what we can conclude about their accuracy, whether they are accurate or not, or means high accuracy or low accuracy. Riba,
They're medium, sir.
medium. I have just two options, whether it would be high or low. There is no option regarding medium. Rehab, tell me, what can you conclude about the accuracy of this particular measurement? This center is your true value, and all of the experimental value are away from it. So what we can conclude about it?
So the precision is low.
Low. So it means all of its experimental value are being deviated from its accuracy. So we can say it have low accuracy. Just check whether all of the experimental data are being closer to one another or not.
Sir, high precision.
Good. So it would be high precision. Nida, is it clear to you?
Yes, sir.
Iram,
Yes.
Rehab, any doubt?
So why is the precision high?
Just in the next third question, all of these particular experimental data are closer to the centermost part.
Sir,
So we can, yes,
in the second example,
yes.
why is the precision high?
Precision means, as we have discussed in this particular part, the closeness of experimental data within themselves. If they are closer to one another, it means they have high precision. Means all of the experimental value is being measured from the same instrument. So they must be closer or they must be identical or equivalent to one another. Okay.
Okay.
In the third example, all of these four experimental data are closer to the centermost part. So we can say it have high accuracy, but on the
And low
basis
precision.
of one another, they are far away. So it would have low precision. Similarly, this segment, all of these experimental data are very far from this particular center. So what we can conclude about it?
Low accuracy and precision.
Low accuracy, and all of them are being apart from each other. So it would be low precision.
So in the second example, the accuracy must be high because they are close to the central point.
No, they are not close to the centermost point. They are very far from the centermost part.
No, in the second example.
I have
Second.
written they have
No.
high accuracy.
In the second example, the accuracy should be high, not you have read low.
I have just written on the basis of this part. And on the basis of precision, they are not closer as well.
Okay.
So if you compare accuracy and precision, they are more closer within themselves as compared to the centermost part. So we can say they have high precision, but having low accuracy. But in this example, they are more closer to the centralmost part as compared to within themselves. So we can say they are not closer to one another. So they would have low precision, but they are closer to the centralmost part. That means they have high accuracy. Is it clear?
Yes.
Yes.
Riba,
Yes, sir.
Sabita, is it clear?
Yes, sir.
Okay. So we have just defined how to define accuracy and precision. On the basis of this, there is one more topic, that is significant figure and rounding off. You all have just know about this particular rounding off method, but just let me define you this particular significant figure. For calculating any of the, or for measuring any of the experimental value, let's say if you have a scale and you have put it on a rod, let's say this point. So on putting Let your zero start with this point. It would be 1, 2, 3, 4, and so on. If you make further division, let's say 1, 2, 3, let's say it has 1, 4 division in it, 1, 2, 3, 4, and so on. So there is a possibility, depending upon the individual, to look at this particular value by 3 different ways. First, if someone sees this particular term from this way, it would look like, or it would say, it would be around 3 according to this angle. But while looking from the other way, from this side, it will be around 3.2. But on looking perpendicular to it, like from this point, it would be just 3.1. So on the basis of that particular observer, by which way he is observing that particular length, depending upon the scale. From this individual, it would be just 3.0, and from this, it would be 3.1, and from this, it would be just 3.2. It would be possible, depending upon the observer. Is it clear to everyone?
Yes.
So we can say this particular all measurement, whether 3.0, whether 3.1, whether 3.2, in all of these 3 situations, the first value, which is 3, remains the same in all of the measurement. But there is some uncertainty about this particular value, 2, 1, 0. It may change according to the observer to observer, whether he or she has taken the observation correctly, perpendicular to its alignment, or at some deflected angle. It would depend. That's why its value would be changeable. So we can't sure about this particular digit. So we can say this is some uncertain digit for this particular calculation. And this is your certainty, or we may call it as true value for that particular measurement. Is it clear to everyone?
Yes, sir.
Rehab, is it clear what I've just defined? Nida, any doubt?
No, sir.
So for any of the calculation in experiment, there is some digit for which we have certain about, for which we can define this is your true value. There must be one digit after it, or the last digit of any experiment for which we would be uncertain. It would depend, or it may change according to the observer. So the total number of digits in any of the experimental value, true value plus one uncertain digit in combination is called significant figure. So if anyone asks you, what do you mean by significant figure? So you must say, while calculating the experimental value, the total number of digits in the calculation, true value plus one uncertain digit in combination will give you significant figure. So we can define the total number of digits true value plus one uncertain digit in combination for any of the experimental value is called significant figure. Now we have certain rules regarding calculation of number of significant figure depending upon the experimental data. Okay. So first of all, write it down. I'm giving you some rules how to calculate number of significant figure in any of the experimental data. Just write it down. Abdullah, any doubt till now?
No.
Aram, any doubt?
No.
Good. Rehab, any doubt? Riba?
No, sir.
So have you all written?
Yes, sir.
Have you all written? Mohammed
Yes,
Ubaid,
sir.
Yes.
Rehab, done?
Yes, sir.
Rishan, done? Good. So let me explain you some rules for counting significant figure for any of the calculation. Significant figure is valid only for decimal number. Otherwise, it would be meaningless. First rule is all non-zero digit are significant. It means if you have 4.2, 3.51, it has two significant figure, it has three significant figure. So all of the digits which are non-zero are called significant figure. Next one is if there is zero. So it would have something different rules. First is if zero lies right to decimal and left to non-zero, then that zero is insignificant. It means 0.04, 0.005, and so on. So all of the zero which lies right to decimal but left to non-zero. This is your non-zero digit. This zero is left to non-zero and right to decimal. So it would be insignificant. So we have only one significant figure in this. Similarly, these two zero is left to a non-zero digit and right to decimal. So these two would be insignificant. So we have only one significant figure here. So this zero and this zero would be insignificant. Is it clear to everyone?
Yes.
Muhammad Umar in just 5 minutes. Okay. Third,
Sir, if it will be 4.0, what?
just
will
I'm
be-
giving you this option. If 0 lies in between two non-zero digit, then it is significant. Suppose if you have and so on. Just see in this particular term, we have two non-zero digit and there is zero in between. So all of these three would be significant. Similarly, we have two non-zero digit and there is zero in between. So this zero and this zero in between any two non-zero digit are significant. Is it clear? Is it clear to you, all of you?
Yes. Yes.
Rehab, any doubt till now?
Sir.
Okay, just write it down. All done? Sabita, done?
Yes, sir. I finished.
Aram, Riba, done?
Yes, done.
Okay, so just we'll stop here. I will continue in next class.
Sir,
The
sir,
rest of the, yes,
please check my doubt.
okay, just 1 minute. Just see, we have a non-zero digit here. So if there is zero, which lies in between any two non-zero digit, whether it would be right of decimal, left of decimal, or any of the condition. If there is two non-zero digit, which is just covering them, then it would be significant. Okay, Umar?
Okay, sir.
Good. So we'll meet in our next class. Just try to revise all of the term or topics which we have discussed in today's class. Okay. And try to solve the assignment. Okay.
Okay, sir.
Okay then. Take care. Good night.
Good night.
Thank you.
Thank you. Yes, Abdullah. Tell me your doubt. Please speak out. Abdullah, are you there? Abdullah? Are you there? Yes. Tell me the topic which you are lagging in. Do you have any doubt in dimensions, in calculating dimension?